Microsoft MVP as well. And we are going to talk about design and how you design your applications for universal platform. Like Lori mentioned, that now Windows 10 supports a large variety of devices. So when you create the application, you target this application not just for laptops and big PCs. You can run this application on devices like this small IoT, sometimes headless devices, and scale it up to laptops, big PCs, or even can run it on Xbox and Surface Cup. So anybody knows what is Surface Cup? So Surface Cup. Okay. So Surface Cup, it's like big touchscreen monitor, and it's another Microsoft product and designed for conference room and for sharing information with multiple people. So, how we can approach design for all these devices? How we can design applications that can be equally good for all these different screens and different form factors? How many people have Windows 8 or Windows Phone 8 applications on the store? Okay. So maybe you know, or maybe you experienced that with Windows 8, Microsoft had a really strict set of rules how applications should be designed, which fonts to use, colors, how it should behave, and sometimes they even rejected applications based on violation of these design rules. With Windows 10, this time is gone. So what they now recommend? They recommend to use your own brand, your own style for your applications. So with Windows 10, like Lori said, or he showed in Visual Studio, you don't even have multiple templates. In Visual Studio, you have just one template, blank, which encourage you and all developers to create all applications from scratch and use your imagination to create your own device and your own experience in your application. So, but if you still have some need to support or to fuel your imagination, you can go to Windows 8, see how applications are designed, and follow the standard. But it means that the application will be just another application, it's like Windows 10 application. If you will forget anything from this that can, you will sleep the rest of this camp. I just want you to understand and to remember one thing. All your sizes, everything, what you're doing with your UI should be scaled or should have measures 4 by 4 pixels. So what I mean that if you have image, it should be clearly dividable by 4. If you have some gaps, all these gaps should be dividable by 4. Why it's important? Because Windows automatically will scale your UI for different devices, and it uses measure of 4 pixels to actually scale up and scale down all your controls, images, everything. So if you follow this rule, your UI will be crisp, clear, and well scaled for different devices. If not, you will see some artifacts. And this scaling algorithm is really smart. So we have different devices. Some devices like phone, we hold them really close. Some devices like laptop, they're on a middle range. And then we have Xbox, and then we have this hub, Surface Hub, which are really far from us. So what they decided to do, they decided that the user wants to see the same elements on different screens in like different, the same perspective. So they are related to each other, all elements should be similar, independent on which screen you are presenting these elements. And to describe this idea with a small video, we have here some block 100 by 100 pixels, font or text, 100 points, and text 24 points. So on mobile device, this block will be presented as 100 pixel block. Then on medium device 150, and on big screen it will be 200 pixels. Okay? And if we are now moving further, okay? So, but if you put them in perspective, we use this device differently. So as I said, phone is close to us, tablets usually further, and if you put them in perspective, because of this scaling, for all of these devices, we will see them as similar size. So you don't need to think about on which device you present. Because of this scaling, automatic scaling made by Windows, your relative positioning, relative sizing between elements of UI will be scaled and modified correctly. Any questions about this? Because sometimes it takes time. So you don't need to change anything. You don't need to think about DPI, screen size, what device will present your UI. Just trust scaling, and it will scale your controls accordingly. And this one, the idea of effective pixel. So all things that we design in XAML browser, in XAML Designer, in Blend, we design in effective pixels. We are not designing in physical pixels. So when Visual Studio, when Windows scale our UI, it actually translates these effective pixels into original or actual pixels. And effective pixel can be one pixel, one physical pixel, or it can be more. It depends on which device currently you present in your application. Again, this is new idea, and you should always design your application with effective pixels. And if you're using Blend and Visual Studio Designer, you always use effective pixels already. Okay, so this is just introduction. So how to design? Again, you have all these different screens, and what Microsoft recommends how to approach all these designs. Then you first should target key form factors. Then you recommend first to think about fonts and think about vertical layout. Then you can think about tablets and small screens, like 13-inch displays. When you're done with these designs, you will cover most of the devices with the scanning and automatically support from Windows. And then, if it makes sense for your application, you can create special experience for big desktop screens and TVs, for Xbox and for Surface Cups. So the idea is that you will target key devices first, and then think if it makes sense for you to support bigger screens. If yes, you can go and create unique experience, not just auto-scale screens, but something that really can make your application shine for this unique experience. And here, just the idea that across the phones, start across 5-inch devices. For tablets, the most important for you to target 8-inch devices, and for tablets, start with 13-inch. And here's an example of mail app, standard mail app from Windows 10. What you can see here is that for big desktop, they have 3-column interface, which represents a lot of information, everything what they can represent. So then, when you try to minimize this application, it actually reduces the number of columns, so it removes one column and show just 2 columns. And this will be interface for your big phones, tablets, and and small phone and tablet. So then you reduce it even further, and what we have small UI for big phones, where you have more information, and finally for really small cheap phones, you have really condensed view, where everything is compacted. And as an example, I will show you calculator app. Close this. Duplicate. Calculator. Okay, so it's too big for this. So this is standard Windows 10 calculator, and here it presents everything. So all information it can present. Now I am reducing width of the application, and you can see that it adjusts how information is presented based on the size. So I reduce it even further, and you can see some information is hidden. So it doesn't display history anymore. I reduce more, and you see size is smaller, and less information is presented. And what we have now here is basically the same UI you will see on your phone. So it's the same application, and this is phone UI. Something like this will be on your tablet, and if I use it like this, that's what you can achieve on big screen like this laptop or desktop. Also, when you design your application, we see that we should adjust our UI for size of the screen, but also think about input. So, for example, if you create application for Xbox, you will not have mouse, you will not have keyboard. You may have keyboard, but usually Xbox users have just joystick, and you need to adapt your UI for new input type. It's the same if you have laptop. You have good keyboard, you have mouse, you have plenty of options for user to enter some data. This phone is less usable, so you need to think how to allow him to input some data. And again, rely on scaling. So if you don't need some unique experience, just let Windows do the work and scale your UI for you. I showed this demo of calculator that they change UI. So what's the main ideas? What principles we should use when we design our scalable forms? So how many people actually web developers have experience with web development? Come. Yeah. So you should be exposed already to responsive design. I think it's now must-have knowledge for web developers. The same idea here, the same principles. Microsoft called it 6 R's. How to design your responsive applications. Reposition means that you just modify how your controls located on the screen, left, right, or from top to bottom. Resize, easy. You resize your screen, and controls are resized. Reflow. Here, this idea that you can change how text presented. For example, if you have a small screen, you have just one column of text. If you have a bigger screen, you can have multiple columns of text. Reveal. It means when you resize the screen, you can show or hide some controls. If you have more space, you show more information. Small space, you will hide some information. You replace idea, you just replace one block of information with another. For example, for phones, you can show some simplified control. And the architecture, if some devices need a really different architecture, you can introduce completely new pages and allow your user to browse from one page to another. For example, for fonts, usually we need more pages to allow inputs or additional messages. Here's just simple example from Microsoft how we flow, actually position works. So we have for big device buttons, and for small device it just moves this button on button. And this is really easy to implement. So Microsoft provides built-in technologies like visual states and new adaptive triggers that allows you to do these modifications directly in XAML. You don't even need to go into code in C# or behind view model to do something like this. It's completely XAML based, and I will show you later how to do it. And again, we have lots of these nice features. We can rely on Windows to scale, but if you're saying that your application needs some really unique experience for some devices, don't be afraid. Create new forms, new layouts, and it's also really easy. This is my second demo, show how you can create a separate view just for some devices. So, now theory, let's talk about what it means for us as developers, what tools we should use to design all these things. So first, you have Visual State Manager. So how many people know what is Visual State Manager and use? How many people use XAML? Okay. So Visual State Manager is not a new idea. We had this before, and it allowed us to change state of our XAML UI from one to another. But before this, we had this through the code. So we can define in our XAML code a couple of views or several views, and then in code we can say, okay, switch my view in state A or state B. As you can see here, we can define different states, and then use go to state to actually switch between states. It's similar like, I think it's called media query, like in CSS. Same idea. You define some queries and then you use them based on false. But for Windows 10, Microsoft introduced idea to make it in XAML without actually coding, because they introduced these adaptive triggers. You can see adaptive triggers, and there are two triggers by default. One is min Windows width, and one is min Windows height. So these adaptive triggers allows us directly in XAML to change layouts based on size of the screen. And additionally, because we have these triggers, yes, but what else? How these triggers are applied? Now we have setters inside of Visual State. Again, for people that worked with Visual State Manager before we were forced to use storyboards, and it's really lots of lines of code to modify some properties. Now we can use setters to directly set some properties of classes and objects. So basically we have triggers to identify size of the screen, and we have setters for the properties to modify some properties of objects on the screen based on the size of the screen. And I will show you in the demo how these two things are combined together. And the last thing that was introduced to simplify this responsive UI is a relative panel. So relative panel is a new container in addition to stack panel, dock panel, grid, which allows us to say that control A should be on the right of control B, or control C should be below control D. Just simple relation between different components, but it allows you to really simply adjust your layout based on the insights. And Okay, let's see the demo. Any questions about what I just talked? Yes.
So you're building this adaptive UI and it's scaling and doing different things. Is most of the elements anchored relative to what, like, say, your first element in the upper left corner? Is that how, when you develop this, is that how you kind of anchor it when you're trying to?
So usually you divide your application in some blocks of functionality
Yeah.
that you want to present for different screens. So what I would recommend, think about your application, what is the minimum information you want to present. This will be your one block of information. It can be like stack panel. Then think what you add for tablets, what you want to add for big screens, and this will be your biggest building blocks.
Okay.
Then inside of these building blocks, think about controls, and they will be all these controls will be positioned inside.
Okay.
And again, inside of these building blocks, think what you want to show, hide, or change, or show differently for different screens. And go deeper like this.
Okay.
I have a question for you.
Yes.
Using the visual state manager there, are you able to account for which type of landscape or which side of landscape you're using? For example, like the calculator on Windows Phone. If you flip it to landscape to the left, you get one set of buttons, and if you flip it over to the right, you get a completely different set of operations. Is that handled more by the visual state, or just?
For this, you can handle this with Visual State Manager because you can control width and height.
Yeah, you know I could control width and height, but I didn't know if I could control
But
content.
yeah,
based
it's
on
content based. No, Visual State Manager doesn't support this.
Okay.
So you need to go with different layouts for different landscape and.
Yeah, I mean, you can use a context manager for the
Yeah.
different templates or different layouts. I just wasn't sure if you could incorporate it all.
No, so Visual State Manager doesn't support this.
Okay.
Okay, so now I will go to Visual Studio. And I will show you a really simple demo about this responsive controls. And then with demo labs you can try by yourself and I can talk with you if you have any additional questions. So I'll go with new project. And again, as I said, we have just blank app. Before we had different predefined templates, not anymore. Take some time. Okay. So we have our application. And we have our main page. This. So simple page, just one grid. And I copy this. What I will drop here, so we don't wait me to typing. This is template for Visual State Manager. So I'm defining here that I have Visual State groups. I define one group. And I define visual state. So inside of this visual state, I will define something like this. So I define trigger. And here I define adaptive trigger, which is main Windows width, and it will be, let's say, 400. So I have a trigger that will trigger this state if my Windows width is more than 400. And then I need to do something with the state. So for this I have this setter. So what I will do, I will say center. And what I will change, actually I need to change name for this grid. equal width. So I will say is width dot and value equal. Okay. So if our window will be larger than 400 pixels in width, then background for this window will be color. And I will add one more state. I will just copy this. And for second state, I will say that if it's larger than 0, then this should be light green. Okay? So let's run and see how it behaves. Still building. Okay, so it's scroll if I make it. So the simple trigger to change it is that it's a really simple example, but you can apply it to any property of any object in your layout. So not just color, you can hide, show something, you can change size, you can change font size, font type, so all possibilities are here. And I don't like to see line typing, so instead I will show second example as an existing solution. Just what I will do, I will open a recent solution. And here I added the use of related panel. So I will just describe what's going on here. It's the same grid, it's the same two groups. One is for large window, one is for small window. And okay, I will have here 600. So, but I also added relative panel. So we have this relative panel that I described before. Inside of this panel I have two text blocks. And one text block is described as text label, and actually the second one is text box is text editor. Then for my visual states, I added one more separate. When my window is big, I'm saying that for text edit, it should be right of text label. If my window is smaller, I'm saying that text edit should be below than my text edit. So now, if I will launch it, what result you will see? Okay. So now we are in a large state. We are Chrome. If I will make it smaller, we change color and we reposition our controls. So basically this is how the calculator goes. If it's large, it's one state. If it's smaller, it positions the control. Okay. Any questions about this? Then I will switch back here. And we'll show you last trick how to adapt your application for different things. You can, it's actually two tricks. You can create your own custom triggers. You saw that there are two triggers, but you can create your own triggers which will modify your behavior based on the settings. And turning back to your question about layouts, about portrait and landscape, you can use this custom state trigger to actually detect different layouts and adopt your UI based on layouts or some specific conditions that you define by yourself. And yeah, just remember about the state trigger base, and you can derive your own trigger from this, and all powers later. So, and the last trick that you can create completely separate UIs for different devices or different device families. There are two options. One, you can create a completely new page and use navigation to navigate to different page based on files. So, for example, here you can see the device family is text box. My application will navigate to the main page text box. For all other devices, I will use navigation to the landing page. So you create two completely separate pages and work with it. Another option, use another new Windows 10 or Universal Platform concept called XAML views. XAML views represents set of views or set of XAML controls without code behind and associated with the same code behind and the same view model. So again, you can have one code behind and multiple layouts for different devices. And just quick demo how it works. I will return here again. And what you see in Solution Explorer is that I have new folder. So I just created new folder. And in this folder called device family dash mobile. Oh, sorry. Yes. Okay. So what you see here, new folder. This is just folder, nothing special. You click on project, say new or add folder, and you need to call this folder device family dash and then what device you're targeting. In my case, I call it mobile, and then I created additional XAML view. So I'm not creating XAML page, I'm creating XAML view. Okay, let's show this again. So I go here, I say add new, and instead of creating blank page, I create XAML view. So blank page, create new page with XAML and code behind. XAML view, create just XAML. Then I call this XAML the same way as already existing XAML. So I have main page, and for my mobile devices, I create main page again, main page view. And Windows Platform will understand this convention and will use this new main page just for mobile devices. So if you already saw how this application behaves for my laptop, and if I will switch to device emulator, and if I will launch it, I should do it before because it takes time. So maybe I can show it later when it's launched. So for mobile device, it will show this new page instead of showing the UI for the full desktop experience. So before it's loaded, while it's loading, any questions on design, on triggers? Everything's clear? Okay, so then back to slides and then we'll return back and see if you're done here. Oh, okay, no. Yeah, so it will take time, and I'll just show you that. You see this page? Yes, you don't see. So as you can see, this main page is completely different, and I can create a unique experience for any device, and device families are different. It's a mobile, it's Xbox, and desktop. So three main families.
So, what color application of which? So, the problem is where's the application developed in devices?
Application
Do you even
no.
no?
So this is convention, and Windows platform understands this convention,
Oh, so it's
and they do it for you.
Oh,
So
you
you
need
don't
to-
need to blame someone.
You need to name for the specific cases.
Yes, yeah. So it's in documentation. You can go to design for Windows 10 and they list all device families. So basically you need to say device family dash and then family. Mobile, desktop, Xbox, IoT. Four main families. If you use them, you can list your XAML views, and operating system will select appropriate view for the device where you're running the application and replace ones that are available outside of any device family support. Yeah, so unfortunately it's like when I'm connected I don't but the link, it will be a different screen, it's just one hello text. Nothing else. Okay? So, yes.
It looks like most of these apps are like small, compact, fast applications. Has there been any like enterprise size apps developed? Is that, are they big and more complex?
I developed, yes, for Windows 10. Yeah.
So it's being done, right?
Yes, yeah.
Okay. Is there any special architectural considerations for that? Or?
So, yeah, you need to use this. I don't use relative panel much, and I heard some of Microsoft people also saying this maybe not the best control to use, but triggers, yeah, use triggers and they help. You can really build application like mail and calculator just with triggers without relative panels.
And I'm just wondering if there's any size limits or performance limits.
Oh, no. Unlike WPF and first reincarnation of WPF as WinRT, this one is really optimized. It's inside of the core. So this XAML, unlike WPF, is actually part of Windows. So Microsoft moved XAML stack from native, so almost third-party library into the core of Windows and recreated it using C++. So it's really optimized, and they copied lots of different features from WPF. Yeah, they sacrificed features to improve performance of XAML. So I really like performance.
So that's inside of Microsoft Windows, but if there's somebody else using other devices, can you use like an enterprise app from other devices?
It should be a device that runs Windows 10.
Oh, okay.
So any device that is capable to run Windows 10 and it could be from Raspberry Pi to phone, laptop, HoloLens, anything like this can run Windows 10, and this will be executed there. And they guarantee that performance will be good. If Windows 10 can run there, then performance will be good. And about performance, it's maybe a little bit outside of my topic. If you are developing a Windows 10 application, look at compiled binding. So they introduced new type of binding. It's compilation time binding. So instead of it depends on reflection, using reflection in runtime to do the binding between view model and view, they introduced new type of binding, which is strictly typed and actually compiled. So they generate additional code in compilation time, and this code link your view model with your view in compilation time with all checks and with really increased performance. So if you care about performance, then look about this new xbind instruction, and it will be compile time binding. Any other questions? Okay, thank you.